Hello guys, welcome back to the channel. This is Rosario Borgesi and today we will discuss Coinbase SDK. So we will create an API key, we will see how to use the SDK to create a wallet, to transfer funds, whether Ether and or USDC, and we will also see how to send a transaction to a smart contract, how to read data from a smart contract, and also how to create a smart contract. So let's get started. Coinbase SDK allow us developers to interact with the blockchain, and in particular it allows us to create new wallets, to deploy smart contracts, call the functions of the deployed smart contracts, and also transfer funds. It is very similar to Ethers.js or Web3.js or VM, but it is specifically created for developers. In fact, it allows a more simple blockchain interactions when performing trades, transfers, staking, or on-chain interactions. It supports Node.js, Ruby, Python, and Go, and it brings also an enhanced security with the multi-party computation MPC that allows for a more robust private key protection with the Coinbase managed wallets, and it supports multiple networks, primary base as it states, where developers benefit from a rich suite of Coinbase developer tools, but additionally supports Ethereum, Arbitrum, and Polygon, and more networks are coming. And a very important feature is that allows gasless sends for USDC, URC, and in particular this is allowed, this gasless transfer of these stable coins on mainnet, so only on the mainnet. And multi-party computation is a cryptographic technique that splits the private key into multiple shards, eliminating the single point of failure. MPC wallets support different levels of security, and there are two kinds of wallets. We will use the first one, which is the developer managed wallet, which is ideal for rapid development and testing, but it has a lighter security using traditional full private keys. Or there is also the Coinbase managed wallet, where you have a shared key management with Coinbase. In fact, it splits the private keys into multiple shards, and it is recommended for production environments. The solutions that can be built are automated one-to-one payments, agent kit, global payment solutions, in-game economies, and fintech innovations. There are a lot of demos in this video, but we will focus on the basic operations that we can do with this SDK. So let's go to the quick start page. In this page they explain how to create wallets, send fund on chains, and in particular we will, after we have created our wallet, found it with Faucet, testnet Ether, And also we will try to transfer funds between wallets. And so we can start by creating a new project. We can do it here. I create a new folder. Now I open the terminal. I start by creating a new node project. So npm init -y. Okay. Then we can add the Coinbase SDK. We start adding TypeScript. Okay. Then we can add also Coinbase SDK. So npm. Okay. Now let's open the project on Visual Studio Code. This is the project, and now we should add a new folder here, src. Then we need a tsconfig.json file, which I have copied from my another project. Okay. Then we need to add, let's add two scripts here. One here we put build, and we put tsg, then we put start. Okay, but you should node this /index.js. Okay, so here we put our file, new file, index.ts. Okay, let's put console.log hello world. Let's add the terminal here. So we start with the yarn start. It was better here to add maybe tsc, and let's see if it works. So npm run start. Okay, it works. So we have the TypeScript, that is fine. Okay, now I believe we also need to install at types/node. Okay. Okay, perfect. Then we need also to add, of course, .env. Beautiful. Okay, I believe that we have installed all the dependencies that we need. So coming back to our quick start, the first thing we have to do is to create a CDP secret API key. I have created already one, but okay, I have already registered. Let's create with this button a new API key. I will create another one. Okay. So create the download. Okay. It will download the API key name and the secret. These two information will be used later on when we will create the wallet. Okay. So we go back to our code. Here we create a file .emb. We create two variables, which are Coinbase API key name, and the second one is Coinbase API private key. The first one is the API key name that we have copied before. This is the secret. Okay, so the two information that we copied before, but they get also downloaded automatically by Base. Okay, now the next thing to do is that we should create a new wallet, and here in this example it creates the new wallet with this expression here. It is importing the configuration from the JSON, and then it creates the wallet with this expression here. But there are also other ways to do it. For example, if we go in this part of wallets, you can see that the CDP SDK provides two pieces of information to persist a developer manage the wallet: a seed, which is the classical seed, the 32-byte hexadecimal string, which is used to derive all private keys in the wallet and provide access to spend the assets in the wallet, and then a wallet ID. And we can store this information once we have created the wallet. Okay, like before with the create with this create method, we can persist the seed phrase locally. Okay, by using this function here, save seed, which is the one that we will be using. And we can put this parameter encrypt to true if we want to encrypt the wallet seed with our CDP secret API key. Okay, then to reinstantiate the wallet, we will use load seed. Okay, so we will use this example here. Okay, so going back to our function, so we can create a main. So function main. Okay, we call this main here. Now we can start to create a new wallet. For example, we can create new constant. Let's say wallet equal to a weight wallet dot create, and we pass inside the network ID. It defaults the network. It is defaulted to Base Sepolia, but it is a good practice to specify it. Okay, now of course we need to import everything. Okay. Yeah, I forgot, I think, no. I forgot here to put async. Okay. Perfect. But before that, I should have called. I don't know if it is done also here. Okay. Because here it is. Here we are. Here we are creating the wallet. Okay. Like it has been done here, but we had to call before another function, which is this one, to the configure method to make use of the APK name and the private key that we have saved in the .m file. So here we put process.env.coinbase API key name. Okay, and then as the private key process.env.coinbase_API private key. Okay, now we should make sure that because I have to import .env from .env, and then I should call .envconfig. Okay. Configure. Yes, this is an object. I forgot this. Okay, maybe I have to put APK name. Private key. Okay. Now say that this is present, this is present. Okay. Okay, now we should call the save seed method. So we say wallet.save seed, and we save it into a file called myseed.json. Okay, perfect. And then we we could also console log something. For example, console.log backticks. Okay, I managed to add the backtick. I had some problems, so I wanted to add some log here. So seed for wallet, let's say I forgot the dollar wallet dot get ID. Successfully saved to my seed.json. Okay, good. So we should also add so this creates my wallet, our wallet. So this maybe this main function could become okay, let's leave it right this way. Extract to function module scope, let's say create wallet. Okay, perfect. I don't like very much this way of writing things. So equal async okay, let's see if it formats the code. Perfect. Okay, so we have our create wallet function, and here we are not encrypting it, but if we put, for example, in the true, it will encrypt the wallet, and we can only decrypt it with the API key and the secret of our account. So let's run this file here. So yarn start npm run start. The problem is that we have to move this thing here. Okay, let's try now. Okay, so it has saved the information here. This is the ID of our wallet. This is the seed which is encrypted. As you can see here, there is encrypted true. So this function creates our wallet. So now another thing, we don't want to create this wallet every time. We now need to write a function to load this wallet. So we can do something like that. We can extract this to a constant. Okay, seed part, for example. Okay, we put this thing here. Beautiful. Okay, now this thing we put here also. Okay, format the document. Okay, now we can create another function called load wallet. So const load wallet is equal to async. No, I forgot the caps. Const load wallet equals to async. Okay. No. Now we can write the const file equals to fs dot read file async. Okay, here we put file path okay, right, UTF-8. Here I am missing an import. Quick, no. Maybe it is. What is that? This next, no. This is next good. This is seed path. Okay. No. So import fs from fs, right? Read the file. It's read the file sync. Okay, it was wrong, misspelled. Okay, so this is our file. Now we parse the JSON. So we write const JSON equal to JSON dot parse, and we put our file. Okay. Now we can take the wallet ID, for example, which is the key, equal to object dot keys, and we pass JSON data. First element, JSON. Okay. This is wallet ID. To get the wallet, we should do const wallet equals to fetch await wallet dot fetch wallet ID. Okay. Because it is written wrong, this should go here. Okay. Okay, now we can call await wallet dot load seed. No, JSON, you should take wallet. Okay. No, it is a seed part. Okay. Now we console log console log. I copy the backtick from here because it is not working. So we say wallet dot get ID successful loaded from file path. Okay, fine. And here we return the wallet. Okay, this is cool. And okay, so instead of calling this function here, comment of this function, we call await load wallet. Fine. Let's see what happens. Okay, so the wallet was successfully loaded. So this gives us our wallet, so we could write const wallet equal to this one. We can get, for example, the address of the wallet. It would be console.log let's copy it from here. Wallet address is get default address. Okay, let's see what it prints. I forgot to put the promise. Okay, here we can see this is the address ID, network is Base Sepolia, and this is the wallet ID. Okay, now we could, for example this we can put this in a variable, call it address, default address. Okay, we could, for example, also check the balance by executing wallet const balance equal await wallet.getBalance asset ID. The asset ID should be Coinbase assets it. Okay, there are other assets. Okay, these are all the assets that we can put. Wrapped ethers, ether, way, USDC. Okay, let's see that we want to say how much ether we have. So we say it balance. Okay, console log it balance is okay. Perfect. Let's run it. Of course it should be 0. It balance is here. For example, now we can also fund the wallet with a faucet. It is very straightforward. So we can create a new function, for example, const fund wallet. Okay. We put equal async. Okay. Okay. Here we put in input, for example, the wallet. And the asset ID. That should be a string. So for example, here we simply call await wallet dot faucet, and we put here the asset ID, and this gets us a transaction, so const x equals this. Then we run await x dot wait. Then we could run console found wallet with asset. Okay, perfect. So if we call fund wallet, we put this is asynchronous, so we put fund wallet over wallet, and we put, for example, it. Okay, let's see what happens. Okay, now we see that it balance is 0.01 ether. This is Base Sepolia. Okay, but we could also, for example, found the wallet with USDC. Okay, here rather than this, we could call also, for example, let's comment out this const balances, get balances, no, get lost list balances. Okay, list balances. Let's try this method. Okay, let's see what console balances. Let's see what prints. Okay, as you can see here, we have USDC 0.001 and Ether 0.01. So we can use either methods. They are fine. So let's try now to transfer funds to another wallet. Maybe here there is an example. Asset ID, destination, other wallet. Okay, transaction wait, transfer complete. Okay, let's copy this code here. Let's create a new function, const transfer tokens equal async. Okay, here we put, okay, I put the wallet as an input. Then there is the destination, this called recipient. So this should be destination. What is a destination? It could be a string, a wallet, or an address. Okay. The amount, wallet, amount, what it is? It is an amount. Okay. This is a number or a big int or a decimal. Here we put amount, and here we put also asset ID, that is a string. Okay. Here I clean up a little bit this code. Okay, format the document. Okay. Here we should put asset ID. Okay, let's call now. We don't need to call this anymore. We can call here, for example, await transfer tokens. Okay, we should put the wallet. Okay, the recipient amount, let's put 0.001. Then we need to put the asset ID, which will be Coinbase .assets.it, and then we put the recipient. The recipient would be my address. This other wallet, for example, let's say this one. Let's change the chain to Base Sepolia. Okay, copy it and put it here. Okay, let's run this code. Okay, transfer, destination, status complete. This has been reduced. Okay, it is good. Let's see what happens here. This maybe it has augmented. Let's see if there is activity. I don't know if I printed the transaction ID. Here it is, the transaction ID. Okay. So we can go to Base Sepolia scan. Here we put this transaction hash. Okay. So from this is the recipient, my address, MetaMask. This is the address searching. Yes, this is the address of the wallet that we have created. And so I have received 0.001 ether, so the transaction was went fine. Okay, this here it does not. Okay, the address here, it is the address of the Base wallet A04 804. Okay, this is my address on MetaMask. This has increased and this has been reduced. Here we are also paying the gas fee, so it has also considered the gas fee. So the balance before was 0.01 ether and after it is 0.0089, which is the same that we find here, 0.0089. If I copy this, it should be the same. Okay, beautiful. We were here. Okay, so we have seen also the transfer. Here it talks about trading asset. This can be tried on BaseNet. You can try it on the mainnet if you like, because it does not work on Base Sepolia. Another thing that also we have seen how to create a wallet, how to fund a wallet with a faucet. So we can already see how Base makes our life as developer easier, because this process of funding the wallet with it should be done manually. In other when you do not use Coinbase SDK. So another thing that we can try is to interact with the smart contract. Okay. So here it is the page to interact that describes how to interact with smart contracts. Among the other things that the Coinbase SDK allow us to do, there is also, of course, the smart contract interaction, which means that Coinbase wallet support the write, reads, smart contract deployments and message signing. For example, this is an important thing in my opinion. They natively support the contract interfaces like ERC20, ERC721, ERC1155 without providing an API, while for the other types of contract we need to provide the API. For example, with other libraries we always need to provide an API, but since these are the most common types of smart contracts we interact with, this makes the process easier. Let's remember that the contract API or application binary interface is the way to interact with the smart contract both externally and contract to contract, and it is a file that specifies the methods and the parameters of the smart contract. So here there is an example where it is called the transfer from function of an ERC721 contract. Here there is another example of invoking an arbitrary smart contract. In fact, they are providing the API here, so they are calling the transfer function with the API. And there are also the examples of smart contracts reads. Which means that we query the smart contracts without explicitly modifying their states. So this is an example where we are calling the this is the USDC address, so we are calling the balance of the USDC address, and for the same account it seems USDC base mainnet, it seems the same code. Here it is providing the API and here not. Okay. Okay, we can for example try to read the balance of my account of wrapped Ether tokens on Base Sepolia, for example. The wrapped Ether token, it is an ERC20, so we could call the deposit function and also then the balance of function, and so the first thing to do is to go to block scout, I believe. Okay, and we look for base. Let's see. In reality it is a Base Sepolia. No. Block scout Base Sepolia. Let's find the wrapped Ether token. It should be this one. This seems cool. So let's copy this address. Let's get back to our account, to our workspace, and let's create a new function. For example, let's put this in a custom const wrapped Ether address. Okay, no, maybe you should put this. Okay. We need to put the API to call it. So there should be something like this. Let's put this here. So the API, it is this one. Now it is not perfect. Maybe it should have been better to put it in a file. We can do it later on, but the two we now we should put the two is the wet contract. Let's call it deposit arts. The two is the wet contract, wet contract address. Value is 0. Value is 0. No, sorry, the value is the the amount that we are providing here. I hope that with number it works the same. Okay. From. Maybe we need the from. That is the sender. This is the method, which is deposit. This is the contract address. This goes here. Value. Let's see if it goes. Oh, we should put this in another file. We should put this in another file. Let's see if we can refactor it a little bit, otherwise it is really hard. So let's create a new file here, new folder API. Let's put this new file called wet.json. Okay, we put this here. We will import in this file we can import it this way. Maybe. Okay. Wet API. Okay. And we should put this thing here. There is no recipient since we are depositing the funds. Let's see if it works. Let's call await deposit wrap editors. We put wallet amount, I would say 01. Sender, here there is a problem because sender is this account, so it is it is wallet dot default get default address. Okay, let's see what happens. Here let's print out this. Let's see what prints. DI method not found. Let's see if it prints the ABI. Okay. So we have the ABI. So I have updated this invoke contract here method, the arguments that we pass to this method here. I have put as contract address the wet address, method, the deposit, ABI, the ABI that we have imported before, this JSON here, the amount that we receive from input. I have specified that these are ethers because this specifies, this variable here specifies the asset type of this amount. And as argument, there are no arguments because the deposit functions receives no arguments. You can see it here, the input is empty. So this way I've run the main function where we call the deposit wet, passing as input to the wallet and this amount. As you can see, I have also here console logged this transaction that should be in reality a contract invocation object. It print out the ABI. Okay, all this information, but we can see that at last, where it prints the balances, we now have this amount of wrapped ethers. Okay, so we can also check the transaction hash on the scanner here. Okay, as you can see, we have transferred 0.0001 ether. This is the deposit. In reality, we are calling the deposit function of from. This is the base, the Coinbase wallet. This is the contract wrapped ether. We are calling the deposit function, and we are depositing this value here. Okay, so in the state we see that obviously the wrapped ether balance increases. So in this way we have called a function that executes a transaction. So we are changing the state of the smart contract and also of the blockchain. For example, here we can a little bit improve this console by saying that we only wish to print the transaction hash. So we say that, for example, dollar, okay, transaction executed. Okay, this is the transaction hash. This is called contract invocation. Okay, here we forgot this backtick. Model. I'm missing maybe dot transaction. maybe model. Get transaction. No. The get transaction hash così. Ok. Okay, that's cool. Now let's try to call instead the for example another method. Here we are creating a transaction. Let's try to read from the contract. So login arbitrary smart contract reads. Okay, it should be something like this. Let's try this out. Let's do const balance of const wet balance. We put in input, this is an async function. We put in input the wallet. Okay, let's see how we can modify this code here. So read contract. Okay. Network ID, no, should be Base Sepolia. Okay, ABI, it is wet ABI, contract address, wet address. Let's see if I continue to have this problem with backticks. Let's put this here. Okay, now it should be fine. Okay, there is something that is missing. Account, it is let's say my account, this one. There are 0.0087 wrapped it. Let's put this here. No, let's put it in address. Let's say string. So wet balance of this address. This should be address. Okay, let's see what's wrong here. Okay, there was no need to pass the ABI, which still I had problems. I need to understand how it is possible to pass the ABI, but nonetheless here bypassing network ID, contract address, which is the wet address, the method which is balance of the argument, so the address for which we want to get the balance of in wet. Here I have also installed VM, so to use, because the output here is in big int, so it is in way to convert it in ether. I have used the format ether by VM, and then I just here leave the in the main I just called this method, and if I run again, here you can see the wet balance of this account is 0.0087, which is you can see also here 0.0087 368. So another cool feature of Coinbase developer platform is that it allows to deploy ERC20 tokens, ERC721, ERC1155 multi tokens. Okay, and it is very easy. I suggest you to try because it could be useful if you have other types of contracts. They are not supported. It says that you should contact them in the Discord, but it can be useful to deploy very fast. For example, here an NFT, an ERC20 or an ERC721 or an ERC1155 in a very straightforward manner. As you see, the code that you write you write a little amount of code. Here, of course, invoke contract to if you want to create a transaction. Also here invoke contract to create a transaction, so to mint, and also here to, for example, here for approve. I believe that you should call the read contract to invoke the read methods of the smart contract. So I suggest you to try it. So we have reached the end of the video. I hope that it has been useful. If you have any questions, please drop a comment below. And thank you for watching, and see you in the next video.